let's say if I want to find a gradient at any particular point or given an x value for a curve fx. Okay, and let's say I have a given x value x equals to k, and I want to find the tangent gradient at this point. Okay, the tangent gradient. So all I have to do is I have to find the derivative of that. Okay, derivative of this curve, which is f prime, since it's k, that will be the gradient, the tangent gradient at the point x equals to k. And we have seen this in our previous lesson. So at the point, if any point when x equals to k or b or c, any point, all you have to do in differentiate or find the first derivation, okay, differentiate the function and plug in your x value to find the gradient at that particular point. Okay, because we know for a curve the gradient are different at every point, so the change that happens at each point is what the delta x over delta delta y over delta x is, and that's where we find the gradient. Okay, that's how we find the gradient. So therefore, finding the differentiation and plugging in any x value at uh, inside the curve, okay, inside the first differentiation, you will get the tangent gradient. And if I know the tangent gradient, I know m1 times by m2 equals to -1. So the tangent gradient multiplied by the normal gradient, this is equals to -1. So if that's tangent, the red color line is a tangent, the blue line is normal, because we know tangent and normal multiply gives you -1. Why? Because tangent is perpendicular. Okay, tangent is perpendicular to the normal gradient. Okay, so this is the most important thing. So first of all, you differentiate and plug in any x value, okay, to find the gradient, tangent gradient at that particular x value, or gradient at that particular x, corresponding x value. Okay, so I can find the gradient, and then once I've got the gradient for tangent, okay, given the x value, I can find what is the normal gradient. Okay, because m1 times by m2, tangent gradient multiplied by normal, will give me -1. Okay, so let's look at some example. Okay, find the equation of the tangent to the curve at the given point. So first step, you need to differentiate. So dy over dx equals to 2x minus 5 to the power of 3, and then you differentiate inside, which will give you +2. So 2x minus 5, you differentiate that, you get +2. Now this is same as 2x minus 5 to the power of 3. And the question here, find the equation of the tangent. Okay, so you have to find the gradient of the tangent. How do I do that? Your x coordinate is 2, your y coordinate is 1. We are not bothered about the y coordinate. We just have to plug in our x coordinate inside. We are not bothered about the y coordinate, so just plug in your x coordinate, so which will give you the gradient at the point 2 1. So that's +2 minus 5, and then you cube. So this is 8. 2 times 2 is 4. 4 minus 5 is -1. -1 cube is -1. So the gradient at the point 2 1 is -8. So I have the gradient, which is -8, or dy dx equals -8, and then I have the point 2 1, and I can find what is the equation of the tangent. So y equals to mx plus c. You plug in y1, and then your gradient is -8, your x coordinate is 2. From there I can find what is c. So 1 equals to -16 plus c, so the y-intercept is +7. So the equation of the tangent to the curve is y equals to -8x plus 17. Okay, next question. Find the equation of the normal to the curve at the point given. Okay, from the previous example or from the earlier notes, we know, and also we have done this before, tangent multiplied by the normal should give you -1. Okay, tangent and normal are perpendicular to each other. So first thing first, let's differentiate. So dy over dx. Okay, before we differentiate, I'm going to change the form, x squared plus 1. Why am I doing this? Because I'm going to use chain rule. Okay, now let's differentiate. So dy over dx equals to -20 x squared plus 1 minus 2, and then you differentiate x squared plus 1, that give you 2x. So this is excuse me, -40x, x squared plus 1, -2, which I can write it as -40 over x squared plus 1 square. Now plug in the x coordinate inside the gradient, -40 over 3 squared plus 1 to the power of 2. So that's -40 over 3 square, which is 9 plus 1, 10 square is 100. So that will give me -2 over +5, so which is -2 over 5. So this is the tangent gradient. Okay, this is the tangent gradient. But the question requires us to find the equation of the normal. So I have to find, first step, the normal gradient. Okay, and my second step will be using the normal gradient, find the equation. So at the point 3, 2, the gradient, tangent gradient, okay, it's not just the gradient, it's tangent gradient. We got it as -2 over 5. So we know tangent times by normal. Okay, tangent times normal equals to -1. So therefore, -2 over 5 times by m2 equals to -1. So m2, which is -5 over -2, which is +5 over 2. Okay, so the normal gradient is +5 over 2. So find the equation y equals to mx plus c. So the points or the coordinates given, just 3, 2, you just plug in inside. So 2, 5 over 2, x is 3 plus c. So let's do this. So 2 equals to 15 over 2 plus c. So c equals to 2 minus 15 over 2. So c equals to, that's for -11 over 2. So from here we can find the equation of the normal, okay, to the curve, which is y equals to +5 over 2x minus 11 over 2. And if you want to write it in terms of ay equals to bx plus c, I can do that. So 2y equals to 5x minus 11.